Good day, everybody, depending on what time zone you're in. This is Brant Howard, and I was a 20 years plus MAPS member here at CompassData and an ex-board member of MAPS for 6 years. I'm excited to be a part, and we are excited to be a part of this virtual conference. We feel it's important that we keep the message going, we keep our work going. And we're thankful that for the members that have showed up and those that are not members that are been enabled to come with this virtual event. Many of you, we know each other. I'm like Frank, I'm missing the networking and social interaction we get. I'm not going to spend a lot of time on this, but I've been in this business for a number of years. It is a family-owned business with my son and my daughter in the business with us and have been for many years. My wife and I started the business back in '94. I do have one addition in the last 2 weeks. I have another woman in my life. I have another granddaughter to my daughter Jane, which is really exciting. So the Compass family of businesses, you may or may not know, CompassData is the service and product side of our business, which does the ground control and aerial and remote sensing products better from ground to space. Compass Drone is a division of CompassData. We started that business 5 years ago, Hayden Howard and his team, to help bring drone technology to the professionals in the business by providing airframe sensors and also training and services. And CompassCom is an Esri-based vehicle tracking solution that is used for things like snowplow, public safety, defense. It's a higher end solution that's totally Esri-based. There are synergy between the three companies in that CompassData and Compass Drone provide content and imagery for CompassCom. We do work from the ground up. We have long-time relationships with Maxar and Digital Globe and Maxar and the companies there in space. We do use partner. We have the good fortune to partner with many of our MAPS members that own aircraft. We do the drone solutions. We do mobile mapping. We do traditional survey and utility mapping. It is about, as Frank said, not only collecting the data, but delivering something that can be meaningful to the end user. And by combining all these technologies and platforms, we are working more and more every day to provide the end customer with a meaningful end solution that's delivered via cloud, on-premise, through an Esri-based solution or another platform to help people provide safety, efficiency, accountability, and accuracy. So quality is primary importance of us. It is job one, as Ford used to say, and still says. We are FAA certified to provide imagery for airport mapping projects. We're one of the few companies in the world that have this certification. We are certified for the GCPs we collect and also the imagery we produce that's used for authoritative data in aircraft. We are ISO certified for our GCPs and our processes. We have a goal for our ISO deliveries of doing 2% no return survey on the data we collect and 95% accuracy on delivery. We monitor this monthly. We monitor our processes. If we do fall out of bed, we have a change detection and monitoring system that enables us to improve constantly. So our business is about accuracy and quality. We are a woman-owned small business certified. As I said, my wife and I started the business. My daughter Kate is in the business as well. And we are great partners to have and have partnered with many of our MAP members to help provide the best solution for the end client. And the thing about quality today, our archive now is over 60,000 points large globally in over 100 countries. That data was collected at different time spans and in different epochs. Because we have such good geodetic control of that data, as long as the feature you can see from the air, does not go away. We can reprocess it with new base station data to make it current and accurate to today or to whatever geodetic epoch and translation you need. Phillip is going to talk more detail about that. But in today's world of COVID and having difficulty sending people to the field, it's important to have, as Gavin had mentioned in a previous event we did, it's ground control as a service is available from CompassData. We may have data that you can use off the shelf without putting people at risk. So I wanted to speak a little bit from my perspective, and Frank was a nice lead into this, because all the things that he is looking to do require accuracy and resolution. If we don't, as MAPS members, provide accurate data that's used as a base, none of this new development and capability is going to be possible. Good enough is not good enough anymore. The areas that we're going to see coming out of this pandemic and out of this downturn in the economy globally that we're going to see are, as I feel, are listed on the left of this slide. As Churchill and our leaders in World War II were doing, about in 1942, they were planning what Europe was going to be after the war, before the war was even over. We need to start planning today for how we're going to come through this, come out of it, and be better some way because of it. Infrastructure is probably what this country is going to lean on to bring our economy back. I'm hoping, I hope we all are hoping, that transportation, utilities, water, energy, we need vast enhancement and improvements on those systems. Sustainability, in our MAPS meeting in Hawaii, we talked about sustainability of our environment, climate change. We have MAPS members that are focused on disaster recovery in the insurance market today. Public safety and public health, Frank went through public health example today, are all going to be key factors in turning this business around. And of course, intelligence, not only defense intelligence, but our civil government are just doing things for voting and determining voting districts, and business on how business is going to focus moving forward with a remote technology instead of a brick and mortar. These are all things we have a play in. And as we look at the technology of AI, ML, and enhanced workflows, accuracy makes this stuff happen, makes it stuff real. I'm very involved in the real-time and IoT world with CompassCom, and it is providing solutions, especially remote today, work from home, to be able to monitor fleets, monitor what's going on, is becoming a big tool. John Koppel talked about 3D and digital twins. If you don't have a good model to start with, garbage in, garbage out. And we're seeing more of this extracts, transform, and load. If you do not have a good base data set, it isn't going to happen. And automation is happening. Autonomous vehicles are happening, and it requires good base data. How do we get there? Typically, MAPS members have used a photometric process that includes an image, a point cloud, ground control, a DIM, and processing. There are other folks in the industry that do that in a different way. Some of the larger internet providers process the quality in by taking image chips and multiple passes over the same site and using large computer resources to process the quality in. But I think it's going to be a combination of both is where we're going. So the key to what we do as MAPS members is we got to get more accurate, better, at a good price and a quick delivery. CompassData is committed to making that happen. Our ground control is available today and is helping folks get there with subscriptions where they subscribe to the whole archive and then pick and choose what they want, when they want, instead of sending crews to the field. So we're part of this revolution. We want to get us together to get out of this situation we're in globally, and we are here to help. And you have my commitment as one of the leaders of this business. If there's something we can do to help a MAPS organization member or a vendor or someone that needs data, call us. We'll make it happen any way we can, within a budget, within a time frame, whatever you need. We're committed to working through this thing with everybody. So Phillip, thank you very much. If you can proceed now with your part of the presentation.
Thanks, Brant. Thank you so much for the intro. One word about myself. I put a slide up. I'm working with CompassData for a while. When we're talking about accuracy, what's important is geodesy at the very basic level, at the very ground level, and then getting to coordinate systems, projections, and then all these models, 3D models, 2D models, imagery, and vector data. So today we want to do something easy, that we want to talk about CompassAA and CompassTA. These are two pieces of software. CompassAA is the accuracy analyst, and it is designed to check two-dimensional imagery for its geospatial accuracy. CompassTA is the topo analyst, and it is designed to check a three-dimensional model for its elevation accuracy. Both together would be really good for somebody who's working like with big data. Frank Winters in the previous presentation mentioned another way about checking attributes in a data set. However, geospatial accuracy is the underlying layer that geospatial inventory is coordinated with coordinates. On my first slide, here I would like to talk quick about imagery 101, resolution, ground sample distance, and accuracy. They go hand in hand. If we're having a satellite image, as we can see on the very right, that's actually a simulated satellite image with a 1 meter pixel size. We would anticipate a quality somewhere around there. However, if we're talking of that imagery that we saw this morning on the city mapper and the Vexel cameras with 1-2 centimeter resolution, also the accuracy expectation goes up. So very quick, resolution, the size of a pixel is the resolution, called ground sample distance. I earlier looked through the attendee list, and I think Mike Tully is today here. So this imagery, the sample imagery, the man laying in the grass, this is Mike Tully from a drone presentation many years ago, I think 8 years ago. However, we use this sample. It really shows clearly the expectations of the resolution as it gets higher and higher. As it gets higher, we're expecting a higher accuracy. So the accuracy of an image can be defined based on the pixel coordinate. So every pixel has a corresponding X, Y, and Z location, or an image coordinate that relates to the real world, and vice versa. Such a GPS measurement, as we can see it in the upper right, has a relation to the imagery through its coordinate. And at the bottom, we see samples of 1 meter accuracy, or 3 to 5 meter accuracy, or 20 to 30 meter accuracy. Mentioning another word to the 20 to 30 meter accuracy, this is how satellite image comes off the bird. And when we're working with satellite imagery that we frequently do across around the world, then we find imagery coming in like this. We're adding a few ground control points to improve the accuracy. Now I gotta say a word about ground control points. Here are a few samples of ground control points. We're starting at the top left. This was surveyed at the Syrian border from our partners in Turkey. Obviously, we work there with satellite imagery. On the right, also, this is very large areas. This is close to the Arctic Circle in Canada. Then at the bottom left, we have Blaine Horner as he traveled to Sweden. I saw Blaine also earlier on the presentation. So hello, everybody, and thanks to be here. On the very right, I don't think the surveyor from Iran has joined us. And then in the middle, we have a ground control point. It's defined simply on a rock. That's the only feature that was there in northern Canada. We have to fly up with helicopters. Sometimes getting these ground control points can be very expensive. However, that's what we do. We control imagery, and also we verify the imagery, hence control freaks. Over the last few years, we have started working with mobile mapping data ourselves and for companies that do extensive mobile mapping and also smaller projects, county-based. For such data set, surveying the corners of signs has become a go-to. The dividing lines between lanes, posts for the ego positioning of self-driving vehicles. Overall, we have an archive of ground control points that spans around the world, and all these ground control points are available. These are just burning to be used on existing imagery to validate and verify existing imagery. As I mentioned at the beginning, CompassAA and CompassTA are two pieces of software that we have. And the CompassAA software, I'm making a quick, simple walkthrough. The simplicity of the software is something to be really highlighted. However, I don't want to have a software presentation within the presentation. So I decided, let's walk you through. So you load imagery, you load points, also ground control points. You measure the difference between those real world coordinates and these projected coordinates in the imagery and generate a report. That's it. That is so simple. But the report tells the story of the accuracy. Before we go to some samples, I want to just show how the software works. You fire it up, you enter some project information to basically put the metadata into the report. You select some of the statistics to be presented, and you customize your report, include a custom logo. So make it all proper. When you have such a project and you have to hand it over to the county or the city, hand this report along, and it will prove or simply validate the accuracy. How that goes in detail, I want to just show one single point that can be used for this, that is used in such a scenario. Usually you should take 20 points to have a statistical sound volume, but on a single point, we surveyed at the bottom right, the end of the sidewalk, a 90-degree corner. It is visible on satellite imagery, aerial imagery. In this case, it is aerial imagery. And the surveyed point is shown as a green dot. That's the coordinate, doesn't really match it 100%. That is okay. We have the situation that nothing is 100%, and we want to know how precise it is. Assuming that the pixels here are 1-inch resolution, we can say about that this very corner here is within 5 inches of the correct position. And if we're adding this up across the whole AOI, we will get to a statistical analysis of the product. Here comes the sample where something went wrong at one of the corners. It's very obvious. I don't have to lose many words. So the AOI is shown. This was a 9-inch project surrounding a city with a 3-inch collect, and the 9-inch collect had at one of the extremes simply an issue. This has been reported. An updated aerial triangulation fixed this project, fixed this problem. The project was completed. Happy customer, like we wanted. CompassTA, also a simple walkthrough, exactly the same steps: load the data, load the points, calculate statistics, and generate report. Gotta apologize. The third step of calculate statistics is actually simpler. We don't have to click the points. The points simply fall either on a DTM or DSM, and then or point cloud, and the elevation difference is automatically recorded. What are LIDAR checkpoints, for example? We have a LIDAR data set on the right-hand side. Customer was interested in the vegetation encroachment of the power lines, but also he wanted to know, is this data set accurate? How good does it lay at the spot where it's supposed to lay? And we're surveying two sets of points. Let's say number one, such buckets on flat areas, so we can do the typical NVA testing, and at the bottom it would be a VVA testing if also the removal of vegetation is of interest. Here another sample, Traverse City in Michigan, how different points were distributed across 4 or 5 counties, and how different land classes were surveyed in the field and then later compared to the existing dam. And simply straightforward, the delta between a dam or a LAS can be calculated and then given into a nice overview report. I have here a histogram showing in which buckets the differences fall and how many of the points, giving a good overview of distribution and accuracy. And to say some final words about CompassAA and CompassTA, the standard for data verification and validation. It's an easy data quality assessment, accuracy quantification, third-party mode for independent assessment, a standardized summary, and it goes really fast. It's a good idea. Please request a trial license. And after the trial license, we have the question, how much does it cost? We decided for today, we're explaining that the cost is at the level that a cup of coffee a day will cover this. I hand it now back to Brant. He wants to say something about our new website. We have just launched a new website, and I hand it over to Brant.
Thank you, Phillip. A couple other things along the same line. The CompassV&V software was a joint venture between Mississippi State University and CompassData. We purchased the rights to the software and the patents. These are patented products, both the CompassAA and CompassTA products. And they are also certified tools by the FAA. So this is an authoritative software tool that can be used as an app, not only by people that are producing products, maybe large-scale products, nationwide products, or doing just a project, or we feel there's an opportunity for the receivers of data to use the CompassV&V software suite to validate the deliveries they get. How would that work? They would have the app, whether it be the AA or TA app. If they're receiving point cloud data, they want TA. If they're receiving imagery data, they would want AA. They could purchase a few ground control points out of our archive that would be independent control, combine it with app, provide it with the, combine it in the solution in the app with the where the remote sensing data was delivered to them, and get a final QA on the data set for acceptance. So this tool is not only something that's useful for the producers of data, but also the receivers of data. Also, it is helpful when you're doing sensor calibration. If you're a manufacturer of sensors or you're testing hardware, drones, airborne, satellite, this is a tool that's easily used, affordable, that can be used to along the QC or QA process. A couple other things about the ground control archive. The ground control archive that you've seen, every point that's in that database, I'd say 98% of those points have been used by someone to do aerial triangulation to produce a product. And if for some reason there's a bust or a problem, we'll know about it. So the data that's in the archive is tested and true and used. And it's something that is available with a credit card. Call us with a credit card and we'll buy 1 or 2 points. If you see something that you need and you missed in a survey and don't want to go to the field, it's possible we may have something that will work for you. And it's in varying levels of accuracy, from a few centimeters up to tens of centimeters, depending on what your need is with your sensor. If we don't have it, call us. We may have it in another way. Like the ground control in the photogrammetric archive can be used for NVA elevation points in LIDAR. So we want you to think out of the box. Go to our website. If you go to our website and give us a comment on the new website and surf around on the archive, please let us know and we'll send you a coupon for a $10 coupon for coffee on us. We'd like to do that for you. And we appreciate you giving us some feedback on the new website. I'd like to thank you all for attending today, but this is something I realized when I was walking the neighborhood a little while back, and the UPS guy goes by, and you can't shake his hand or say hi to him anymore, or somebody that's delivering something to your house, but I just gave him a thumbs up. And you don't have to touch anybody, you don't have to be close to them, but I want to give a thumbs up to medical staff and first responders in this pandemic we're going through, our field staff and the pilots that go out and do the work that's critical, the delivery services, the food service people that are putting themselves at risk, our teachers that are going back. So I hope everybody will start giving people a thumbs up. You know, you can bump fists or take the more safe avenue of just a thumbs up. And with that, I appreciate your time. I know a lot of people, I think everybody knows about our archive, but we did a couple events this year where only 50% of the people knew of our ground control archive after all these years. So we're trying to get the word out. We're looking to do some upgrades to our software. We need your input. And I thank you very much, Mark. And if there's any questions, there's one here, I think, on AI and ML I can address if you'd like me to. How do you introduce augmented reality and or artificial intelligence? Well, our base data today is being used, and our control is being used today for autonomous vehicles. Another interesting application was they were using our base data on a ski mountain to do automated grooming of the slopes. There's other examples where you can give where machine learning is taking this base data and will be more and more, and I talk to people in public works, where if they're going to do autonomous vehicles in snow plowing or anywhere, how do you know what the base is versus a part of the street where they have construction going on, and how does Tesla know that there's construction going on that street? How does any company know that there's construction? You have to have a real-time way of processing that information and getting out, comparing against a base to make decisions. Our data is critical to that process. And another question was, can every GCP in your archive be relocated? I guess I don't quite understand that question. If you could reach out to me or to Phillip, we'd be happy to understand the question better. But can it be relocated? In other words, is it offset or is there some? It's all collected and stored in one geodetic theme and thematic layer and geodetic time and reference. And from that, we can translate once to another geodetic theme and time and reference. So it's very transportable that way. Phillip did an exercise with the tsunami and earthquake in Japan where we took hundreds of points we had and reprocessed them with the data from the core system over there, and we could see the vectors and shift of the continent very easily. So it's very transportable, very easy to process and give you in the delivery you need. So thumbs up to all of you. Wish you all safety and health in this as we go into the fall. And thank you, Mark, you and the MAPS board for your efforts on our part.
Thank you, Brent. Thank you, Phillip. Always good to hear from you both. Always good to hear from CompassData and have you participate in all MAPS events.